Hi again everyone, welcome to week 3. This week we're going to look at fractional number, something that's often been said to be difficult to teach and hard for students to learn. Now this doesn't have to be the case. In the lecture we'll give you a few ideas, but certainly in your tutorials and workshops you will get many more practical ideas. One of the things I've been asked quite a few times now is people who have said they can't come to tutorials for work or whatever reason. And they've asked if they're recorded. Now we record the lectures so you can look at them anytime, but the tutorials are very interactive and there's really not much point to record them because there's not much to see. Your tutor may or may not put up the slides, but the benefit is actually being there and doing it. And it's hard to learn to be a teacher if you actually just don't turn up. The same as if when you're a teacher, if your kids aren't there, it's hard for them to learn. And I understand all the pressures around jobs and work and all those things, but really the tutorials are things that have to be experienced, not something you can revisit later. So for those of you who have asked me, and there's been probably about 20 of you, this is the reason that tutorial attendance is really beneficial. It's not, you can't fail the course, it's not a course requirement, but if you don't come to tutorials, it's very difficult to really, firstly, get an idea of the content and what we're talking about, and secondly, to learn to be a teacher. Someone said to me, would you want to go to a doctor who'd missed their tutorials? Anyway, there's just the same answer for everyone. I thought if I put it here, it's set for everybody. Now, some common things I've heard. Did you know that 5 out of every 4 people have trouble with fractions? Or one I hear more commonly, who wants the largest quarter, or who wants the largest half? And you can see there's some basic misconceptions there about fractions and fractional number. So first of all, reflect, what is your concept of fractions? When I say fractions, what's the first thing that comes to your mind? What are some of the skills students need to work with fractions? And how can you help them do that? Why do so many teachers nominate it as the hardest area? Now, if you think back to your time learning fractions, I imagine the first thing most people think about is a pizza, and a pizza being chopped up. And the question is when you chop a pizza, do you have a half or a quarter, or is it something else? So the words half and quarter and other fractional numbers like that are used not in a specific quantitative way, but often conceptually in a colloquial way to describe sort of something that's cut up into a certain number of pieces. The other thing to remember is fractional number is not just fractions like a third and a quarter, it's also decimals and percents and ratios as well. In this time we're going to focus on fractional number in the standard way you might have seen it. So fractions. A fraction is just a part of a whole, is what I've commonly heard. And you can reflect about whether you think that's the case. If it's the case, then what's the fraction 1 1/2? Is the 1 1/2 the fraction, or is 1 a number and half a number that's just been put with it? Is that the fraction? If we wrote it as 3/2, would it then be a fraction? How many different types of fractions are there? And I've already talked about them just before. But probably the more important thing is, what things do they have in common and how do they relate to one another? And what makes one type different from another, and when would you use one and not another? Now certainly back in the old days when I went to school, fractions were more important. Well, actually it was probably before I went to school, which shows you how long ago it was, because we had imperial measurements. So once we moved to metric, the need for fractions diminished because our measurements were on a base 10, which therefore made decimal fractions much more useful, much more appropriate. So you've got to think a little bit, how often do students come across fractions as in a third, a half, 7/8, or those sorts of things these days in their real life? How common are they? How useful are they? And when they are used and useful, are they used in the strictly mathematical, exact quantitative sense, or are they used just more colloquially? So here's some things to consider. Which of these is the largest fraction? 1/3, 5/10, or 14/30? Why is one larger than the other, and how do you know? What have you assumed here to work it out? And if you think about those, what are some of the problems you think kids will have? So does it make a difference what number's on the top and what's on the bottom, the numerator or the denominator? What happens to the size of the portion as the denominator gets larger? And how would you demonstrate this to children? So it's not hard to show, but it's quite difficult for students to get a handle on, not because it's hard to show, but because it seems counterintuitive. So if you think of the fractions just listed there, 6 is much bigger than 3, but 1/6 is much smaller than 1/3. So you can see the confusion that arrives. So again, it's relatively easy to show the students what these are, but then you need to link it to these representations in terms of the written numeral, the written fraction there, to try and help them understand and link those connections together, not just to see it in a pizza or a cake or something else that you happen to chop up. So students need to understand the difference between a tenth and tenth. So what you can see here as I listed is some of the language difficulties that come up. These are not conceptual understandings, but they sound the same. Tenth and tenth, it's the same word. 1/10 as a fraction, and 10th place as in a running race you came in the 10th position. And one that might surprise you, the difference between whole and whole. And you know, there's a joke we had about that. I won't go through it now, it's probably not that funny. They need to understand the importance of what's the whole and what's the equal parts, or what's the unit of analysis. And the importance of equal parts. So just because you chop something up into 4 pieces doesn't mean they're quarters. And the problem here comes in their everyday language. Often if you chop something up into 4 pieces, it is often called a quarter, even though it isn't. Fractions are numbers. They're still numbers that can be added, subtracted, multiplied, divided, etc., etc. They're the same as any other number. And they can be put on a number line, and they can be positive and negative. And despite their apparent size, they name small amounts often, except for mixed fractions. So you can see the one I've put there is 98/100. Many students will think that that's a really big number, even though it's actually less than 1. So you'll notice that when you get them to put it on a number line and ask them, where does 98/100 fit on the number line? And in fact, it fits between 0 and 1. So there's lots of different understandings that will interfere here. And often the problem, particularly as you're in early secondary, is you have to deal with misconceptions and misunderstandings before you can help them understand things correctly. So be aware that these are some of the things. Not that they've necessarily learnt these at school, but they would have learnt them just from their everyday life. You'll see the quote from Smith there, that no area of school mathematics is as mathematically rich and cognitively complicated and as difficult to teach as fractions, ratio and proportion. So there's a challenge for you. But it's not impossible, and it can be a lot of fun. It's just a matter of understanding it from the kids and the learner's perspective, and then building from there. So some points there, and these slides are all up in the Learning at Griffith site if you want to have a look at them after. But symbolically, fractions do not indicate the size of the whole. It's the relationship between them that's important. So the numerator or the denominator on their own are not particularly meaningful. It's only the relationship between the numerator and the denominator that's important. And students often tend to focus on the size of the parts rather than their occurrence as parts of the whole. So again, this is where they get confused. The bigger the numerator is, the bigger the number, but the bigger the denominator is, the smaller the number. And of course, there's all sorts of new language to deal with. And some of them are there, and some of them they hear, even when you would say it clearly, they'll hear it in a different way. So be clear of what they've heard and not just what you've said. But it's their language difficulties, and some of the complexity of this area of mathematics particularly rests in the complexity and the difficulty of the language. So we often try and do modelling, and there's the bottom there's a link to some virtual manipulatives. I've put some others up previously in the announcements. But modelling it, I've got a pizza there because that's what we almost always use, a pizza. So what are the advantages and the disadvantages of using some sort of model like that to represent a fraction? One of the problems is almost all the representations we use are round. So what happens if we have a square? What if we have a rectangle or something like that? Students need to see different models and different ways of doing it. And a pizza might be fine, but you want to reasonably quickly move away from something like that because it relates to their real life, which is great, which helps them connect, but it also relates to a misconception of what in a pizza normally an eighth is. You know, if you share a pizza with someone and it's cut into eighths, you can have 3/8 and the other person can have 3/8, but you can have quite a lot more pizza than them if you're careful in which pieces you select. So you can see that there's from their previous understandings from everyday life, they bring forward some misconceptions that you have to deal with. And if you only use things like pizzas to show it, you will actually reinforce their previous understanding. The decimal fractions are also fractions, decimal numbers. And again, since we've moved to the metric system, when your grandparents were at school, decimals became much more important after we moved away from imperial measurements and also pounds, shillings and pence. I just want to say I never did pounds, shillings and pence as well. But what is a decimal fraction, and why is this a new concept, and how can we help students make the connection between decimal fractions and the normal fractions they're useful? Decimal fractions are probably the most useful fractions they learn and the most common ones. Obviously they relate directly to the metric system, but also for percentages, right? But a percentage is just a decimal out of 100. And money, of course, they also reinforce numeration, particularly around place value. So students will understand place value, and this really connects to place value just going to the other side of the zero or the decimal point than just to the normal side where the positive number, the whole numbers are. It's a representative of small numbers. Now, even before, you'll notice I said it relates to the other side of zero, which is incorrect. It relates to the other side of the decimal point, because some of the things students confuse decimal numbers with is the number line where we have integers. So when we get to zero, on one side it's positive, on one side it's negative. In fact, decimal fractions are pivot around the number 1, because anything after the decimal point is between 0 and 1. Again, you can see the connection and the difficulties students might make if you've done it around the time of you've done integers. And the number line. It's important that they see it on the number line, that they understand all the numbers, all the digits after the decimal point are between 0 and 1. Now, some of the difficulties in teaching it is there are very few real-world examples of decimal fractions, apart from the ones we've already listed, like the metric system and money. But it's not often we use decimal numbers outside of that, and sometimes we use them in different ways. And I think previously I've talked about the example when, if you're watching the cricket, when someone's bowling, if they bowled 6 overs, then on the little score sheet it will say 6.1, 6.2, 6.3, 6.4, 6.5, 7. So you can see the same representation of a decimal fraction is used, but it's not actually talking about a decimal fraction at all. So it really builds on place value, and it's important that students have an understanding of place value. And if they don't understand place value, then it's really difficult for them to understand decimal fractions. The key thing when you're teaching it is try not to teach it too mechanically. Try and teach it conceptually. So obviously money and measurement are key places to start. Now, one of the temptations is just to jump straight into abstract representations of decimal fractions without really building a conceptual understanding from context that they understand. And almost always we're going to go for money or measurement using the metric system. But that should precede their understanding of it in an abstract sense. Also, we all, including myself, probably already in this video, will use inappropriate language. For example, the decimal number 9.523, we'll often read it as 9.523. So it's not 9.523, because otherwise it makes it sound like it's a whole number. The 0.523 is between 0 and 1. So if you're doing some computation with decimals, again, I would start with some real life examples as much as you can. And again, it's not too hard to do with money or measurement things. Money obviously good for decimals to 2 decimal places, but measurement you can use a range of things. You'd start with addition with the emphasis on the alignment of place values. When the multiplication and division, the emphasis is on the use of estimation first. So when you do an addition and subtraction, the alignment of the place values is important. So you're subtracting tenths from tenths and hundredths from hundredths and ones from ones, etc. But with multiplication and division, what is key is to use some sort of estimation first. So when I start, I would always ask them to have an educated guess about what the answer is. Because sometimes kids do multiplication and division and they'll make just a little error somewhere and their answer can be out by a factor of 10 or 100. And because they haven't estimated, they just write it down. And then also, it's important they look at rounding and estimation with decimals. What's a realistic answer? So if you're asking a measurement question, and I remember once from an exam, there was a question about 2 boats in the America's Cup on the ocean. And they had to do some calculations to work out how far these 2 boats were apart. So right out in the ocean, in the middle of nowhere, middle of the Pacific perhaps, they had to work out how far apart these 2 boats were. And the answer they gave, some of them gave answers like 52.53729151 kilometres. So in other words, they've given the distance between these 2 boats apart to the nearest millimetre. And in that case, that answer doesn't make sense. They've got to think, what's a reasonable estimation or what's reasonable rounding for this sort of answer? And that should be part of the working with decimals calculation. You don't just write down every decimal that happens to be on your calculator screen. You round it to what would be a reasonable answer for that thing. So some final points. You yourself may or may not be very familiar and comfortable with fractional number. It's likely that if you've got this far in your education, you at least have some sort of computational understanding. You can probably do the arithmetic with it and those sorts of things, even if your conceptual understanding might not be strong. So one of the things for you is to, first of all, get a really clear conceptual understanding about what it means. Make sure you really understand what it means that all fractional and decimal numbers, unless they're a mixed number, are between 0 and 1, and where that fits on the number line. And then when you come to do the arithmetic and things like that with it, make sure you understand why it works, not just how it works. So one of the things you often might hear, I remember when I was at school, when you divide fractions, you invert and multiply. We learnt this rule and we did it. We had no idea why it worked. So you should understand why it works. Why would you invert and multiply? What does that do to the problem? So having a good conceptual understanding for you is really important. And also then you can help the kids have a conceptual understanding, which then makes the computational part of it much more easy and makes more sense. So you have to be able to see these mathematical ideas through the eyes of the school student, even though you can possibly already do it fairly easily. It's not just about you being able to do it, it's how do you get someone who's finding it difficult or who's really naive to these ideas to come to understanding. That's the challenge of the teacher. And if you ever really want to know what that's like, try and teach someone to drive if you've already got your driver's license. Because all of a sudden you've got to go back and think about all those things you do automatically without even thinking anymore. And again, it's really crucial, particularly in areas like fractional number, where often students struggle and sometimes we as teachers even struggle. Okay, that's it for today. Thank you. I'll see you soon.